Hello guys, today we are looking at your quadratic sequences. Remember, for sequences which generally have the form T1, sorry, not Ti, T1, T1, T2, T3, T4, and so forth, sequences have this form. So your quadratic sequences have the equation, they have the general term, Tn equals an squared plus bn plus c. Alright, so remember, these, they look like quadratic graphs, right? They look like quadratic graphs. Alright, so all the knowledge you have of quadratic graphs, you will apply it for this quadratic sequences. Again, you also need to be careful that these are sequences. So since they are sequences, your n is not equal to 0 and it is an integer. Okay, of course, I believe before you watch this video, you have watched the video on linear or rather arithmetic sequences, where we define this as your general term, or if you don't want to say general term, you called it a term value. Right, you called it a term value, right, where this n is a term number. All right, where n is a term number. So we're not going to look at parameters a, b, and c. Okay, so without any waste of time, let's just get into how we can solve quadratic sequences. Okay, so we said they are in the form Tn equals an squared plus bn plus c. So I want you to consider when you have n equals 1, equals 2, equals 3, equals 4, equals 5, and so forth. Right? So maybe I'll try to squeeze them a bit. So imagine this: when Tn, remember, Tn equals an squared plus bn plus c. Now, when n is 1, what is Tn? It is a into 1 all square, 1 square rather, plus b into 1 plus c. Alright? This simplifies to a plus b plus c. Alright? So T1 is a plus b plus c. Alright? Let me not put an equal sign here, but rather say it leads to this. Now here, when n is 2, you will have 2 square is 4. So you will have 4a plus 2b plus c. When a is 3, you will have 3 squared, which is 9. So you will have 9a plus 3b plus c. When n is 4, 4 squared is 16. So you'll have 16a plus 4b plus c. Lastly, when n is 5, 5 squared is 25, 25a plus 5b plus c. Alright, plus c. Now, these are patterns. So for just like you did in arithmetic patterns, you need to find the difference between the first and the second and so forth. Difference between first and second, second and third, just like that. So the difference between this and this, when you look at it, 4a minus a is 3a. 2b minus b is b. C minus c is 0. Now let's consider this. 9a minus 4a, it's 5a. 3b minus 2b is b. C minus c, 0. Again, 16a minus 9a, it looks like 7a plus 4b minus 3b, it's b, c minus c 0. Again, 25a minus 16a is 9a, 5b minus 4b, it's b, c minus c is 0. Okay? Now, as you can see, this difference here is not common, right? What I mean by is not common, I mean it's not a constant, right? So I need to find another difference. I need to find another difference. So 5a minus 3a is 2a. b minus b is 0. 7a minus 5a is 2a. b minus b 0. 9a minus 5a is 2a. I mean, 9a minus 7a is 2a, b minus b is 0. So, here we have a first difference. As you can see, you have a first difference, it is not common. And here, you have a second difference, it is common. Alright? You have a second difference, it is common. Okay? You have a second difference which is common. So, this means quadratic patterns have a common second difference, and arithmetic patterns have a first common difference. Alright? That's the difference. So, that's the difference between the two. So, I want you to highlight this block here. I want you to highlight this block here. Okay? Now, this block, you're going to use it to help you find your A, your B, and your C. You see this? If you can note this, it'll be easier for you. Now, without any waste of time, let's look at some questions on your quadratic sequences. Okay, let's try it. So, example, find the general term. Okay, so we're going to find the general term for number 1, 2, 6, 14, 26, and so forth. Number 2, we're going to find the general term for negative 1, 0, 3, 8, and so forth. Alright? So, now, I want you to look at number 1, and let me change my color for my solutions. For number 1, we had, number 1 was 2, 6, 14, 26, and so forth. I left the space so I can make those differences. So 6 minus 2 is 4. 14 minus 6 is 8. And 26 minus 14, what is it? It is 12. Now, these are not common, so I'm still going to find another difference. 8 minus 4 is 2. 12 minus 8, oh sorry, it's 4, not 2. It's 4. 12 minus 8 is 4. As you can see, the second difference is common. Now, since the second difference is common, this means we are dealing with a quadratic sequence. Okay? Now, remember what I had said to you. I said highlight this. This is 2a, this is 3a plus b. I want to show you something now. 2a corresponds to this 4 here. Look at it. This is 2a. It corresponds to this 4 here. So 2a equals 4. This means a equals 2. We are good to go. Now, we have here, remember, this is the difference between term 2 and term 1. Right? This is 3a plus b. What does it correspond to? It corresponds to 5. So 3a plus b, or maybe let me write it here. 3a plus b equals 4. Already we found a, so this means 3 into 2 plus b equals 4. Now 6 plus b equals 4. Therefore, b equals negative 2. Now check this out. The first term, which we term a plus b plus c, is, it's here, it's 2. Alright, it's 2. So a plus b plus c equals 2. Already we found a, we found b, we need to find c. So what is it? This is 2 minus 2 plus c equals 2. I see 2 minus 2 is 0. Therefore, c is 2. Now, remember, we said Tn equals An squared plus Bn plus C. Just a reminder. Therefore, our general term is Tn equals, what is this? Where there's A, I put 2. Where there's B, I put negative 2. Negative 2n. Where there's C, I put positive 2. Now, as usual, you need to prove whether your general term is correct. So what do? You then say, let me try with T3. Okay, so I'm gonna try, right, T3, where there's n, I put 3. So this is 2 times 9, 2 times 9 is 18, minus 6 plus 2. So this is 14. This is 14, right? This is 14. I think so. Yes, the third term is 14. So this means our general term is correct. Now, let's try the last one. So we have, let's see, we have number 2. We have negative 1, 0, 3, 8, and so forth. Right? So I will still say 1 minus minus 1, or 1 minus negative 1 is 1. 3 minus 0 is 3. 8 minus 3 is 5. Now this difference is not common, therefore it is not an arithmetic sequence. I'm going to move on. 3 minus 2, 3 minus 1 is 2. 5 minus 3 is 2. Okay, maybe let me try to shorten them. 0 minus 1 is 1. 3 minus 0 is 3. 8 minus 3 is 5. 3 minus 2 is 3 minus 1 is 2. And then 5 minus 3 is 2. Again, remember what I had said. I'm going back to that thing. This stands for, is in place for 2a. Let's go back. It's in place for 2a. So 2a equals 2a equals 2. What does it mean? It means our a is 1. Now, we have difference t2 minus t1, which is this one here, which is what? 3a plus b. 3a plus b, what's in place of it is 1. So 3a plus b equals 1. What is the value of a? The value of a is 1. So we have 3 plus b equals 1. This means b equals negative 2. Now, we go into the first term. The first term, we said it is a plus b plus c. I showed you how we got here. So T1 is a plus b plus c. So this is minus 1. So a plus b plus c equals minus 1. Now what do we say? we have A, we have our B. So this is 1 minus 2 plus C equals minus 1. Now, what do we have? We have minus, okay, C will be 0. Okay, C will be 0. Therefore, our general term, remember, we are moving from, we're using this guy here. Okay, we are using this guy here. I will always remind you, we are using this guy here. So what is our general term? It is Tn equals, what is A? It is 1. So this is n squared. What is B? It is minus 2. So it will be minus 2n. What is C? It is 0. So I'm going to leave it like this. Now, I need to I need to check if the general term is correct. I'm going to use term 4. Okay, I'm going to use term 4. Let me test with term 4. Term 4, I have 4 squared minus 2 into 4. This is 16 minus 8. This is 8. Let me see. We have found our general term for this sequence. This is how you find the general term for your quadratic sequences. Okay, guys? All right. Bye-bye.